Hello everyone, today we'll be looking at the quick solutions to the chemistry section of All India AIATS Test Series JEE Advanced 2019 Test 5A Paper 1 Code C and D. So let's start with the first section. This section contains 8 questions. The answer to these questions are in the form of single digit integers. So let's start with question number 21. In the given reaction, so we have been given a aromatic compound which is allowed to react with H2SO4 concentrated to give us a major product Z. The examiner seems to be interested in the number of H atoms present in Z. So he says that if the number of H atoms present in Z is X, then the value of X by 2 is. So let's try and figure out the major product Z which is formed in this reaction. So we have this substrate which is allowed to react with concentrated H2SO4. So what is going to happen is this lone pairs over oxygen are going to attack on this H plus and convert into an oxonium ion, which is a good leaving group. So this OH will convert into OH2 plus and then leave. So this will lead to the formation of a carbocation. Now students, this carbocation thus formed can undergo rearrangement. So there will be ring expansion and this bond will shift to the carbocation, leading to the formation of a 6-membered ring. So the intermediate which will be formed is this. The carbocation will be formed at this position, whereas the other part of the structure will not be affected. Now there will be a loss of proton. So this bond will shift here, converting it into a pi bond. So finally the product which we're going to get is represented by this structure, which is phenanthrene. So students, this is the major product Z which is formed in the reaction. And now if we talk about the number of hydrogen atoms present, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So the value of X is equal to 10 and the value of X by 2 automatically will become 5. So students, for this question we have to mark the answer as 5. Let us look at the next question. Question number 22. Two beakers A and B are present in a closed container. Beaker A contains 152.4 gram of aqueous solution of urea, having 12 gram of urea, whereas beaker B contains 196.2 grams of aqueous solution of glucose, having 18 gram of glucose. Both solutions are allowed to stand for a substantial amount of time to attain equilibrium. How many moles of water are transferred to the urea solution? So if we try and figure out the data which is given to us in the question, we have a closed container. This closed container consists of two vessels, vessel A and vessel B. So if we talk about the container A contains 152.4 gram of aqueous solution of urea. So the total is 152.4 gram. And if we talk about water and urea, so the amount of urea given to us is equal to 12 gram. So the amount of water shall be automatically 140.4. So we can now find out the moles of water and urea. The moles of urea shall come out to be equal to 0.2 because its molar mass is 60. And if we talk about the moles of water present, this shall come out to be equal to 7.8. Similarly, we can talk about the glucose solution. So the glucose solution given to us is 196.2 grams. It contains water and glucose. So the amount of glucose given to us is 18 grams. So automatically the amount of water present shall be equal to 178.2. And if you talk about the moles of glucose shall be equal to 0.1. And if you talk about the moles of water, that shall come out to be equal to 9.9. So students, we can see that the mole fraction of glucose, the chi of glucose is equal to 0.1 upon 10, whereas the chi of urea is equal to 0.2 upon 8. Now students, what is going to happen is because of the difference of the mole fraction of the substrates present in the solutions, there will be a difference in the vapor pressures. The pressure exerted by the urea solution shall be lesser as compared to the pressure exerted by the glucose solution. So what is going to happen is the moles of solvent, which is water, shall shift from the glucose side to the urea side. until equilibrium is achieved. So when equilibrium will be achieved, the mole fraction of both the solutes in the containers A and B shall be equal. So we're going to have 0.2 upon 8 plus X. We've assumed that X moles of H2O have shifted to the urea side. This shall be equal to 0.1 upon 10 minus X. So there is a loss of X moles of water from the glucose side, and there is a gain of X moles of water in the urea side. So the shifting of water molecules will take place until both the mole fractions become equal eventually. So in solving this expression, we're going to have 20 minus 2x is equal to 8 plus x, which on simplification gives us a value of 3x equal to 12. And the value of x comes out to be equal to 4. So students, we can see that a total of 4 moles of water have shifted from the glucose side to the urea side in order for the system to achieve equilibrium. So students, for this question, we have to mark the correct answer as 4. Let us look at the next question. Question number 23. In the following given compounds, how many molecules have linear geometry? So if we try and draw the structures of these compounds which are given to us, we have BeF2. So BeF2 shall be linear. We have N3 minus. So the structure of N3 minus is also linear. We have NO2 plus. NO2 plus is also linear. We have SnCl2. SnCl2 is bent. We have BCl3. Structure of BCl3 will be trigonal planar. We have ClF3 next. The structure of ClF3 is going to be T-shaped or bent T. We have FeCO5. FeCO5 is trigonal bipyramidal. We have H2O. H2O is also bent. We have XeF2. The structure of XeF2 is going to be linear again. We have I3 minus. I3 minus is isostructural to XeF2. And we have ICl2 minus. So this is also a linear molecule. Isostructural to I3 minus. So out of the given compounds, we can see that the linear compounds are BeF2, N3 minus, NO2 plus, SnCl2 is not, BCl3 is not, ClF3 is not, it is also not a planar species. H2O is bent, XeF2 is linear, I3 minus is linear, and ICl2 minus is also linear. So out of the given compounds, we have a total of 6 compounds which are linear. So students, for this question, we have to mark the correct answer as 6. Let us look at the next question. Question number 24. The maximum number of equivalent CLO bond having same bond length in Cl2O7 is X and equivalent CRO bonds in CRO5 is Y. Then we have to comment on the value of X plus Y by 2. So we can try and draw the structures of both these compounds which are given to us. We have Cl2O7. The structure of Cl2O7 is symmetrical. And we can see that there are a total of 6 CLO bonds which are identical. So the value of X shall be equal to 6. If we talk about the structure of CRO5, we have a butterfly structure of CRO5 consisting of peroxy linkages between the oxygens. So we can see that there are a total of 4 identical CRO bond lengths. So the value of Y shall be equal to 4. And if we comment on the value of X plus Y by 2, it shall come out to be equal to 5. So students, for this question, we have to mark the answer as 5. Let us look at the next question. Question number 25. If first dissociation of a base XOH whole thrice is 100%, whereas second dissociation is 50%, and the third dissociation is negligible, then the pH of 4 into 10 raised to the power minus 3 molar XOH whole thrice was found to be Y. The value of 0.5 Y to the nearest integer is. So we have a base XOH whole thrice which is dissociating into XOH whole twice positive plus OH minus. This is the first dissociation. We can talk about the second dissociation as well. We have XOH whole twice positive converting into XOH 2 positive plus OH minus. So the examiners mentioned to us that the first and the second dissociation are significant, whereas the third dissociation is not significant. So we need not consider the third dissociation. Now if we talk about the degree of dissociation, we have been given that the alpha of the first reaction is equal to 1, whereas the alpha of the second dissociation is equal to 0.5. So we have alpha is equal to 0.5 or half. And if we talk about the concentration which is given to us, we have 4 into 10 to the power minus 3 molar XOH whole thrice. So since the value of alpha is 1, the species present on the right hand side will also be present in this amount itself. So this shall also be 4 into 10 to the power minus 3, and this shall also be equal to 4 into 10 to the power minus 3. Now if we talk about the second dissociation, the amount of XOH twice positive formed was 4 into 10 to the power minus 3. And if we use the value of alpha equal to half, we're going to have the concentration of OH minus ions coming from the second dissociation as 2 into 10 to the power minus 3. So students, if we talk about the total concentration of the base present in the system, we're going to have 6 into 10 to the power minus 3, which is the sum of the OH minus coming from both these dissociations. So students, if we talk about the POH now, it shall be equal to 3 minus log 6. The value of log 6 is approximately 0.78. So the pH value shall come out to be equal to 2.22. So if we talk about the pH value, that shall be equal to 14 minus pOH, and it will be equal to 11.78. So the value of Y is equal to 11.78. And if we talk about the value of 0.5 Y to the nearest integer, it shall come out to be equal to 6. So 0.5 Y is nearly equal to 6. Students, for this question, we have to mark the correct answer as 6. Let us look at the next question. Question number 26. The reaction A plus 2B giving us C is an elementary reaction. In an experiment involving this reaction, the initial pressure of A and B are 0.4 and 1 atmosphere respectively. So it is further mentioned to us that when Pc is equal to 0.3 atm, the rate of this reaction relative to the initial rate is x. So we have to find out the value of 100x. Students, we have A plus 2B converting into C. The initial value of the pressures are given to us. It was 0.4 atmosphere for A. It was 1 atmosphere for B. So if we talk about any time t, 0.4 minus x, 1 minus 2x, and the amount of C formed shall also be equal to x. So it is given to us that the value of x is equal to 0.3. So the pressure of B at that instant is equal to 1 minus 0.6, which will give us a value of 0.4. And if we talk about the partial pressure of A at that instant, will be equal to 0.4 minus 0.3, which is equal to 0.1. So we can talk about the rate of the reaction now. So rate at this time t shall be equal to k into 0.1 into 0.4 whole square, as it is given to us that the reaction is an elementary one. And if we talk about the initial rate, the rate constant is not going to change as the temperature is not changing. So it shall be equal to k into 0.4 into 1 square. So the examiner seems to be interested in this ratio. So rate at time t upon rate initial is equal to 0.1 into 0.4 whole square upon 0.4 into 1. So this will give us a value of equal to 0.04. So this value comes out to be equal to x, and the value of 100x shall be equal to 100 into 0.04, which will give us a value of 4. So students, for this question, we have to mark the correct answer as equal to 4. Let us look at the next question. Question number 27. How many maximum spectral lines are possible if electron is present in third excited state and only 3 atoms are present in the sample? So we have to keep in mind two things in this case. That the electron is present in the third excited state, which is n equal to 4. And there are a total of only 3 atoms present in the sample. So we can have the transitions. So n equal to 4. When it will be excited, it can go to n equal to 3, n equal to 2, or n equal to 1. So we can first have all possible transitions. So we can have the electron coming down stepwise. So this will be the first part. We can have it coming in this fashion and in this fashion as well. Or we can have the electron coming down directly. So we have a total of 4 different paths which are possible. So 4 different paths are possible. But it is given to us that there are only 3 atoms present in the system. So we have to select any 3 of these 4 different paths which are possible. And since we are to deal with the maximum number of spectral lines, we can have path 1, we can have path 2, and we can have path 3. Although it will not make much difference if we use the path 4 as well. So if we count the total number of lines which are possible, we have 1, 2, 3. This has already been counted before. We have the 4th line, we have the 5th line, and we can see that this also has been counted before. So we can have a total of 5 different spectral lines which are observed. Students, the correct answer to this question is 5. There are a total of 5 different lines which are possible if there are only 3 atoms present in the sample. Let us look at the next question. So in question number 28, the examiner has given us 2 different complexes, A and B, and the examiner seems to be interested in the total number of geometrical isomers possible for these given structures. So if you talk about the first complex which is given to us, we have COEN NH3 whole thrice H2O. The charge on the complex is 3 positive. If you talk about this complex, so we have a bidentate ligand En, and the geometry is octahedral as it is clear to us. So we know that En can only span the cis position. Now if you talk about the ammonia ligands can all be cis to each other. So this is one of the isomers possible for this complex. We can also have a case in which the ammonia and the ammonia are trans to each other. So we can have NH3 trans. So the H2O can be at any of the other 2 positions. So these are the 2 complexes possible for this form. So we can see that the value of X is equal to 2. If we talk about the second complex now, which is given to be COCN whole twice NH3 whole thrice and H2. The charge on the complex is +1. So we can have cases in which the ammonia are all cis to each other, and we can have both the cyanide ions as cis to the ammonia which is labeled, and the H2O can be trans. So this is the only isomer possible in which all the ammonias are cis to each other. We can now have case in which the ammonias are trans to each other. So if we talk about that structures in which the ammonia and the ammonia are trans to each other, we can now have 2 cases in which the cyanide ligands are trans to each other, whereas in the third possibility, we can have the cyanide ions as cis to each other, whereas the H2O is then going to be in a trans position. So students, these are the 3 isomers which are possible for this given complex. We can have the charge on them as well. Okay. So students, we can see that the value of Y shall be equal to 3. So X was equal to 2 and Y is equal to 3. And we have to comment on the sum of X plus 5. So that shall come out to be equal to 5. So students, for this question, we have to mark the correct answer as 5. Let us look at the next section, students.